Welcome to Inside Builder channel, large language model automators, Python experts, and my dear friends. Exploring the power of embeddings with clustering. How to convert the raw data to decisions, insights for saving cost and life in certain cases. We are going to build bridges between the data, the raw data that you have got, and we are going to create insights out of it. And all of these things is going to happen with embeddings. If you're new to this embeddings concept, I would suggest that take a look at this particular video where I introduced embeddings. And also, if you're pretty new to artificial intelligence, machine learning concepts, then I would suggest to take a look at these series of videos. As I make these videos are at the top. You can actually take a look at these videos in my playlists. You can always look it up, and I will also be attaching these videos along with this particular discussion that we are having. Getting back to the presentation. The challenge that we are solving in this particular discussion is to understand where and how the embeddings are used. In the video where I introduced embeddings, I had informed how to create embeddings, how sentence transformers libraries can use, and what are the various models that can be used for creating the embeddings. If you are new to embeddings is nothing but conversion of text data, the text data like real life application, this sentence gets converted to numbers. And to convert these numbers, we need certain models, and those models are what the sentence transformers library has got. Let us go back to the browser for a moment so that I can show to you what I mean to say. So if you go to sentence transformers library, that is sbert.net, you will be able to see the various models that is available, the various usage, as well as the various examples that is already provided. If you go down to the models, if you go down to the pre-trained models, you will see the various models that I'm talking about. Let me zoom in a bit so that you guys can see it a little better. So this is what I was talking about. There are various models, and you can learn about that model from this particular documentation or from the video that I was speaking about. Now, in this discussion, we are going to see how to use the embeddings and where it is getting used in real life. This real life application that you see here, to segment a market, to create image segmentation from the image, find any anomalies in the data that you have got, understand the usage of the land. If you're a geologist, you can actually take a look at the land usage, or if you are from the telecom networks or any other kind of a networks, then you can use the network usage analysis. You can use search engines. Search engines actually use the clustering also. Cross encoders are one of the ways to use it, and image search. All of these applications use embeddings in one way or the other. The most crucial aspect that we are going to discuss in this video is about clustering. Why am I talking about clustering? When you have numbers, and that too when you have a lot of numbers, and when you put them on a particular graph, so a graph like this, immediately, and once you put these points on the graph, and if you give colors to the graph, the points based on their categories, you will immediately see that they can form various clusters. The numbers, when it is placed, as I was explaining, on the graph, and when it is colored, you can immediately see the clusters. That is what we are going to see. And in order to go with the clustering algorithms, we are not going to manually cluster it. As I was telling, we cannot take the embeddings and put it on a graph. We are going to let the mathematical algorithms do it for us. Out of those algorithms, I have listed a couple of them here. So first and foremost, there is partition clustering that is done by k-means, if you are aware of scikit-learn, and we will be going through some of the examples also. K-means is one of the algorithms. Density-based clustering is kind of a soft clustering. So there is something called as hard clustering and soft clustering. Partition clustering, k-means, comes under hard clustering, meaning you have to tell how many clusters are there, and the number of clusters will be created out of the points. When it comes to soft clustering, the clustering is all depends on the points, the data that is available. It is not decided by how we want it. So that is the difference between soft and hard clustering. density-based clustering, distribution model-based clustering, that is density-based partial clustering and noise. It is called as DB-scan. This is one of the most prominently used algorithm in the market. Hierarchical clustering, like agglomerative clustering and affinity propagation, both of these. And finally, we have fuzzy clustering. All these are the various types of clustering, and also clustering can be used kind of for different application. Like you can use it for recommendation application also, and you can use it for finding new kinds of customers for you. So once you do the market segmentation, so there can be other applications that is not listed here. As I was telling, if you go down that, there can be other applications also. Of all these applications, you might be wondering, see, these are applications that we may not be using day to day, right? And these applications also will, the applications of these kinds of algorithms are usually behind the front end, or it is usually done in the back end. So it actually happens, the magic happens in front of your eyes when you look at any of the recommendation system giving you a particular recommendation, for example a movie or a product that you want to buy. But at the back end, what kind of algorithm is being used, it is something of a mystery. So once you understand these algorithms, that mystery will be removed. Okay, so we have seen the real life applications and the clustering algorithms that we can work upon using embedding. But I already told you that we are not going to manually plot those embedding points. We are going to let the algorithms do it. And algorithms by themselves, you don't need to write. All the algorithms, in fact, most of the algorithms have been already written by the researchers. All you need to do is you should know which library, Python library, you have to access and reach out for getting the clustering done. So here are various ecosystem of libraries that is working with the embeddings. So it starts with sentence transformers, and next is BERT topic. So this is one of the most important library that will be coming, that will be diving a little bit deeper in this discussion and more deeper in the next discussion. So this is one of the libraries, and it is very famous. This particular library has a lot of applications when it comes to topic modeling, and it is written by Martin Groot and Dorst. And you can actually see the details in the citation. So whenever you're using this particular library in your application, or if you're using it for your project, do cite this particular, provide the citation when you're doing it. It's a good way of sharing the credibility to the people who are using your product or project. Now, let us go back to the presentation. So here you see there are lots of libraries that I have listed. So there is BERT-topic, there is Pickle, SafeTensor, that is KeyBERT, sklearn, HDBScan, Transformers, PyTorch, Hugging Face Up, Rapids. In fact, all of these libraries solve one or the other challenge. And all those challenges I have listed it here. So sentence transformers, what kind of challenge it solves? It provides the embeddings. It is the core library which hosts the model, and it provides the embedding for us. In case of BERT-topic, it creates topics, it models the topic. So what is topic modeling? So let us go back. Okay, instead of going to that, let us come here. So assume that you have a lot of sentences like this. So assume that this is all the input data. So 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, and all these 6 sentences you converted into the graph like this, and you cluster it. Okay. The numbers are, the text is converted to numbers, and the numbers are put on the graph and they are clustered. But how can we find out what kind of topics this particular red circle is going to discuss, this green circle and this black circle is going to discuss? How will we find that? That is where topic modeling comes to picture. So topic modeling is, we are not going to dive deep into the algorithm that is used in topic modeling. However, the topic modeling starts with creating the embedding, and then it reduces the embedding dimensions. All these things we will see in a little bit in detail in a couple of minutes, but I'm just giving you an overview what is going on. So that is the thing. And BreadTopic does the topic modeling. When it comes to pickle and safe tensor, helps you to save the embeddings that you create. We have been already talking about, one or two, maybe even if there is 10, 15 sentences, you can embed it whenever you want. But if it is going to be 10,000, or even if it is going to be, 1,000 sentences, it is better to embed the sentences and save it for later usage. Even if it is going to be from a free open source model, the resource that you need, that is the compute resource that you need to create the embeddings, still cost you money. For that purpose, it is always better to save the model. And for that, there are two ways. You can use either safe tensor or pickle libraries. When it comes to keyword extraction, so you can use keybird. If you are going to talk about sklearn, it is a huge ocean in itself. sklearn is mainly for ML machine learning, that is machine learning algorithms, which starts from regression, k-means clustering, and XGBoost algorithms and cat-boost algorithms. So these algorithms had come before neural networks came. And these algorithms don't use transformers; they use pure models, algebraic models, to come up with the correct answer. I had been discussing about the modeling concept in the earlier videos. There I had spoken about AX plus B equal to C. So that AX plus B equal to C kind of models is what sklearn deals with. HDB scan is high density, as I was explaining, high density based spatial clustering and noise. HDB scan is used when the number of sentences that you need to embed is in tens of thousands or even in millions. At that time, HDB scan is what is getting used. Transformers, there is no introduction required for this. I have been covering Transformers library for a long time right now in my series of videos. Take a look at my playlist where I talk about open source models. And PyTorch. PyTorch is the library that helps to create neural networks. I mean, it builds it from the bare minimum tensors. It starts from PyTorch tensors and starts creating the models one by one. And you guys might be new to backpropagation. It's a kind of an algorithm which helps you to learn, which helps the model to learn the data. All of this is done by PyTorch. So there are other libraries in parallel to PyTorch, like Flax, Tensor. Just a minute, excuse me. TensorFlow was the model I forgot. And then Hugging Face Hub. So this is a hub that stores the neural network models as well as the embedding models. Rapids is one of the libraries that helps to speed up the algorithms. So like whether if you are having pandas data frame or a sentence transformer model, or you are going to work with any of the repeating algorithms, if you are going to use Rapids CUML, that is CUDA ML related libraries that is created by Rapids, then it can actually do the working through the GPU. So these are the various libraries. All these libraries are available for open source, and you can get the information from the internet just by searching for it. I would urge you guys to do the search. The intention of my videos is for kind of breaking the barrier. Whenever I come across these libraries, I face a kind of a barrier, because you see there are lots of documentation involved. So let me actually show you the example. So let us go for an example, BreadTopic. So if I go to the BreadTopic, you immediately see that it is having a lot of quick start, and it talks about modularity, and it goes on. And once you go into the details, so say for an example, if I go into multi-topic distribution, and that itself, it creates another series of things that you have to learn, and it continues. So you see here that the amount of information that someone has to understand looks really daunting, and the developers who write this documentation, they have put their maximum effort not only in writing these writing the actual algorithms underneath all this documentation, but they've done a very good job when it comes to writing the documentation also. There's no doubt about it. But the barrier that I face, at least, is to look at these documentation and go through these documentation step by step. It's a time consuming activity, right? And we don't know how much time it's going to take. I want to reduce that time. So when I create these videos, I try to dive, give you a overview, and directly dive into the application where you see the code. So when you look at that, and when you go back to the documentation looks easier. That is one of the key point that I'm trying to work it out. Do let me know. Give a comment about this, whether it is working out or you need some kind of different way of introducing these libraries. With that said, let us go back to the PDF again. So this is just an introduction that I wanted to provide. Next, what we want to do is we want to actually think a little bit about the nature. So you see, when I'm talking about all this clustering, you might be thinking, why does these clusters happen? Does nature really has these kinds of clusters? To be honest, no. Nature, in fact, does not have any kind of clustering idea inside itself. What happens is, when as human beings we like to cluster things, and it is easier for us to learn and understand the reality when we categorize the reality. So we want to categorize the things that is living and non-living. We want to categorize things that are hard and soft. It is inbuilt into our learning mechanisms. In fact, it is inbuilt into our brain neural networks. So what we do is, whenever we come across these kinds of data, we want to put these clustering circles. If you indulge me for a minute, so we want to put the clusters around this around the data points and try to understand it better. So nature just creates, and we as human beings create the clusters, right? And what to do with the outliers? So always this question arises. Yes, most of the times the clusters that occurs in the nature is not perfect. There will be lots of outliers that is in the middle. So for an example, there will be hard and soft material, and there will be something that is in the middle, which is kind of a soft and hard kind of a thing. Even in case of, we see liquid, gas, and solid, and there is one more kind of a plasma object, that a plasma kind of a material that we come across. Same way, new data points, new information always provides us with the opportunity to create new clusters. When it comes to these outliers, they are also important, because they give you an important information about a different kind of a cluster which you may not be aware of. So keeping those outliers is very important until you know that these outliers are not going to impact your results. Because see, at the end of the day, if you think plasma as something as an outlier, and if you don't learn about it, then probably one fine morning that plasma is going to come and bite you, right? So we have learned, if you guys are new to physics, or if you guys are new to science, then plasma may not make a good example. The better example will be to think about ants. We come across ants always. At our houses we come across ants, and we know two types of ants based on the color, black and red. And what if in later point of time you come across a brown ant, and that brown ant does not eat any of the eatables, but it eats only wood, and that is called as a termite. Like this, you come across new information, and then you learn a lot more. So clustering and outliers are also important until the outliers don't matter anymore. Model that can choose which bag the data point will go. Once you create a cluster, so assume that you have already created a cluster, but you have got a new point. How will you make the model in such a way that it will directly take the point and put inside a particular bag? So that is where the algorithms comes into picture. We will be looking at that, how it is being done. There are various kinds of mechanisms, like using distance mechanism, or using agglomerative clustering, or using hierarchy. So there are various ways to take a new data point and then place it inside a particular category. The next challenge, when the number of points increases, instead of 1,000 points, if it is going to be 10,000 points, or 100,000, or a million, there is going to be lots of points. How are you going to work with such a huge amount of data? How are you going to cluster it? What kind of whether two-dimensional will be sufficient? So all these questions will arise, and there should be a way around the challenges. And yes, the data that you see here is two-dimensional, but the same graph can be converted to three-dimensional clusters also. So you must have already come across lots of these beautiful clustered scatter plots in the internet, where if you click on the, I'm not showing any of the websites, but you can actually come across these time and again. So if you go and click on any of the points, and that points will pop up with the data. So like that, you can create data out of it, and it is really cool to look at. As I was explaining, there can be clusters within cluster also. Like there can be, this particular 4 points can be a separate cluster, and this particular 3 points can be a separate cluster. Nothing is going to stop us to make clusters within clusters. And finally, what if I don't know anything about number of clusters available? What if the data is totally new? How are we going to deal with it? And that is where unsupervised learning comes into picture. So these are the various questions that might arise when it comes to clustering. So I felt I need to give you some brief about all these questions and how to answer them. We will be looking at the program, the code, in a couple of minutes, but before that I felt we need to discuss about that. The final questions: what about the topics? So we have already placed the circles, but how to find out what topic this particular clusters are? That's where BERT topic comes into picture. So BERT topic has algorithms built in which can model the topics. And to model the topics, there is not one method. There is all these methods, various types of method to model the topic. There is almost 10 different methods. And all these methods have different input data, the data arrival timing, all these things change. So for an example, first and foremost is the approximate distribution of topic. So we'll be seeing all these examples in the next video. Stay tuned for that. I believe that you will like this content. Do leave a like and share it with others. Most importantly, do subscribe to the channel so that once I upload any new videos like this, it will directly be updated in your YouTube dashboard. With that said, I would like to further continue regarding the various kinds of topic modeling. The topic distribution by approximation is very similar to k-means, but in this case, we don't give the number of topics that is possible. So we let the model find it out for us. In case of online topic modeling, is more like getting the updated data time and again, and the topic model updates by itself. There is supervised, semi-supervised models, manual topic modeling. All these kinds of modeling depends on how much you have control over the topics that you are going to model upon. So in case of semi-supervised, you give a particular list of topics, but the rest of the topics are devised by the model itself. In case of supervised topic modeling, all the topics are provided by you. In case of manual topic modeling, you learn from the model and start guiding the model. So all these things are going to happen online when the code is when you are running the code, and these kinds of code are better run on Jupyter Notebook, where you can understand the things much better. Finally, there is coming the dynamic. All these examples I have also explained it here. How to work on manual mode, how to work on supervised mode. All these steps are provided as the methods inside the BERT topic. The point is, it's not just the methods. It's about how we feed the data into the methods. That's where the actual challenge challenge occurs. So for that only, I always continue explaining the theory. After that, I go to the discussion of the code. So we will be diving into the code. The code that we'll be using for this particular discussion will be shared with you guys, and the code is available. Just a minute. The code that we are going to discuss is already uploaded into the GitHub repo, and this particular repo link also will be shared with you guys. This code has been taken from the various documentation that has been provided, not just from sentence transformers. I have taken it from topic modeling, but topic library also. So this is one of the additional step I always do, where the examples are directly taken and the data, how the data is fed into the model, is shown to you. Whenever you see how the data is fed, it is much easier for you guys to understand how the model is working. At the end of the day, it is all about the data structure. but you don't need to keep the data structure in your mind and learn the data structure as if to get 100 marks in data structure exam. That's not the intention. The intention is to use the data structure for solving a challenge that you have. So that is my primary objective as usual for all the discussions that I have. Now to continue, what I am doing is initially I am using the k-means clustering from the sklearn. I am using the sentence transformers to do the embedding. So this embedding process I am not going to explain. You can take a look at in the earlier video. I have explained it in detail. I am going to use this list of text, and immediately you can see these three items, these two items, and these two items, and these items are looking like a separate cluster by themselves. So once you read it, you will understand it by yourself. Now the point is whether the model or the clustering algorithms can they find it. In fact, they can. So I'm going to say that this cluster is going to have 5 numbers. This data is going to have 5 numbers of clusters, and then I initiate the k-means clustering algorithm. That is the object. Once I do that, I just have to fit the data model on the embedding. So here is how the embedding is getting created. Embedding mini-lm.encode, and the embedding is created. And this embedding will be series of numbers. And once I fit it, and you will see that it has created the clusters. And it has created 5 clusters. And once you look at it, so this particular function takes the cluster as well as the sentences that is provided earlier, and it creates a data frame along with the cluster. So you see this three sentences that we saw in the beginning, that is under cluster 0. This related to the girl is under 1. Related to the man riding the horse is 3. The monkey and the gorilla come under 4, and cheetah comes under cluster 2. So you see that just by using numbers and k-means clustering, which is not even machine learning, it's not even artificial intelligence model, it's a ML model. Okay, if you guys are thinking what is the difference between ML and artificial intelligence, it's very, very simple. ML models are based on algebraic equations. Artificial intelligence models are based on neural networks. ML model, the way of convert the number of parameters are very limited. In case of artificial intelligence neural network models, the parameters can actually go in billions. With the latest large language models that we guys have come across, that is ChatGPT, Palm, and various open source models like Falcon, OPT, and ChatGPT for all these models are in range of 3 billion to 540 billions. So yes, neural networks, artificial intelligence models are huge. So whenever, if you're new to industry, you might be a little confused in the beginning, but at the end of the day, see, whether it is an ML model or an AI model, all you are going to do is send in numbers to the model, and you are going to get out numbers. So if you're from a background from a non-tech background, you really don't need to worry about how these models are created. But if you want to learn, if you want to dive deep into these things, yes, then you have to understand these basics. Let us continue. In case of k-means, I had provided the cluster number, right? But in case of let me go up, sorry, I provided the number of clusters here. So here, in case of agglomerative clustering, there is a next step, and that also I'm going to use sklearn only. In this case of agglomerative clustering, I am not going to tell how many clusters. You see, I have provided it as none here, but I'm going to say the distance threshold is 1.5. So what does this mean? What is the distance threshold? Let us go back to the presentation. The distance threshold here is the gap between 2 points. So in agglomerative clustering, what we are telling the model is that we are giving it a constraint that the maximum gap between the points should be 1.5. And if it is the case, then make it into a single cluster. And in order to do that, the agglomerative clustering algorithm has to do a repetitive task, and finally it gives us the cluster. So let us see how is the output. I am not actually diving into any of the algorithms here, as you have already seen. My intention is that all these algorithms have been already written. So here, when I instantiate this particular object, agglomerative clustering object, then I get get the method, fit method, on which I can give the data, the normalized embedded data that I create here using this formula. I can just place it here and it can fit. And once I fit it, you see that it is again creating 5 different clusters. And you see, I did not tell to create 5 different clusters. By default, agglomerative clustering is creating 5 different clusters. So now you might be always wondering, okay, how does the clustering algorithm know that there is 5 clusters? To be honest, it doesn't know. So if you go up, and in case of k-means clustering, if you say, instead of giving 5 clusters, if you ask it to create 3 clusters, it will still create. At the end of the day, it is not going to say that it cannot create, that it has to create 5 clusters. No, it's not going to do that, because it doesn't know. It is just following your inputs, human inputs. It looks, when someone explains, when you look at the model, when you read about these in the news articles or in the media, it feels as if the model knew that there are going to be 5 topics, or it knew what is going to happen next. But in fact, no, it's not the case. If you go and change it to 3, and if you try to run this algorithm, it will still run and you will get a different result. Do practice. So I always, whenever I talk about these things, I always say that you have to practice. The reason why I tell this is that is how you can really understand artificial intelligence and the Python ecosystem. Okay, let us go back to the presentation. As we continue further, so we had a brief introduction about agglomerative clustering. So we saw that we have various ways to create clusters right now. But all these clusters are just numbers. But how to find out what these clusters are representing? That is where the BERT topic comes into picture. But before that, there is one more bigger challenge with us. What if there is a huge amount of data that is in the tune of 100,000 or 200,000? How are you going to manage that? One such data is the Quora questions and answers. You must have come across the website, the application Quora, and you know what the application does. So people post questions and other people post answers, and the best answer gets more upvotes, and things happen that way. But there will be lots of duplicate questions and there will be lots of duplicate answers. How to find out the duplicate questions and remove it? This is one of the challenges that was Quora, that was available even on Kaggle as a competition, and till date there can be duplicate questions available in the database, Quora database. So how to remove them? That is where the point of clustering comes into picture. And not just that. So first point is that you remove the duplicate questions. For that, you can use embedding, and you can try to see how 2 questions are similar together, and we can remove it. And that is one thing that you can try. But even then, some of the duplicate questions can escape. How to find that out? So that is one of the challenges that this particular algorithm does. It takes around 50,000 questions, and it embeds the question. This is the embedding step where it gets embedded, and then once the embedding completes, so you see it takes, so all these 50,000 questions are getting embedded. But here you see I am asking to create show progress bar. So this particular progress bar is shown once you give this input, and this particular progress is telling 782. This is 782 batches of 64 questions each. That is how the entire corpus of 50,000 sentences are getting embedded. And you see it has taken almost 11 minutes 20 seconds. So embedding takes time. And when you are going to have huge amount of data, it is going to take considerable amount of time. So keep that in mind. It's not going to happen immediately. When you are going to give 10 sentence, 20 sentence, depending on your system, it looks really fast. But when it goes in hundreds or even in thousands, it's going to slow down. This is one of the main reasons why you need to be aware how to use it in production, how to use embedding in production. Because if you're going to have lots of people connecting to your service and you need to embed their query online, then there is going to be a bottleneck. So keep that in mind if you're thinking about using this technology. Yeah, if the query is going to be if the user query is going to be taking 1 minute to build, and the user expects the answer in say 10 seconds or 5 seconds, it's still fine. But if it is going to be less than 5 seconds, like as if it is going to happen in real time, then it is going, you need to have a very good pipeline built there. Okay, so that is one of the digression. So here I am using something called as community detection. So this is kind of a algorithm that is provided by sentence transformer itself, which can do the clustering for based on a very huge amount of data. So that is called as community detection. It's a new name for clustering basically. And here it takes 52 seconds to build the clustering output, and it creates 61 clusters. So out of 5,000 point data that you have provided, 61 different clusters has been created, and you have to review the clusters. So how to review the clusters? So you see, this is the next two steps: creates data frames out of the various data that you have got, out of the clusters as well as the sentences, so that we can take a look at it one by one if you want. So you can filter the clusters, and you can see how the questions are linked with the clusters. And also you see there are other ways of looking at the clusters. So there might be, out of 61 clusters, there might be one cluster which is having some 100 questions, and there will be one cluster which is having only one or two questions. So those clusters could be complete anomaly, or it could be outlier also. So you have to check these things one by one, and then only you have to decide. And all these things takes effort and time. Keep that in the back of your mind continuously. Okay, so we have come to a level to a point where we have seen a good deal about clustering, but we have seen the clustering in such a way that the cluster is just a number, 0, 1, 2, even up to 60, 100, or whatever it is. But we cannot find out what this series of sentences are about. I mean, we cannot get a precise topic or topics that these sentences have. And that is where the idea of BERT topic comes into picture. The rest of this particular notebook discusses about BERT topic, and especially about this particular page where I introduce the various BERT topic modeling methods, which I will be diving deeper into the next video, and I will talk about that. In this video, further to close, before I close, I want to talk about one thing very important, that is saving the embeddings. So in order to save the embeddings that you create after creating this question, after embedding all the Quora questions, it is always better to save it. You don't want to do the embedding again. As I explained, sentence transformers model are free, but the compute and the time that is required to model, to create the embedding is there. Still, you have to spend that time. You can use a simple pickle library, and you can dump the entire embedding as pickle, and you can store it. So it will create a pickle file, and you can later pull it out. And after you create the pickle file, you can load it using the load pickle file, and you can get the embeddings back. That is one of the way. But this is the easiest way available if you are going to only do the embedding storage. If you are going to work with the topic modeling, so in case of BERT topic, there is a different way. BERT topic directly integrates with the Hugging Face hub itself. So I will be diving deep into this in the next video, and also we will be seeing a couple of other ways to store the embeddings. With that said, I would like to review it's kind of a little longer video that we have covered the main objective of clustering. What are the real life applications that you can find in clustering, and how to actually begin the clustering process. I have not gone through the entire application. If you have seen, to complete an entire application or entire project in clustering takes a lot of trial and error and iterative process. I don't want to give you a false thought process that by just watching 45 minutes or 1 hour of video, you can actually cluster the credit score rating, or cluster the cancer cells. Actually, no, it's more involved. You have to understand the data. You have to become one with the data. As one of the developers, Luton in Transformers says, you have to become one with the data. And to become one with the data, you have to look at the data in various fashion. And embedding is one of the fashions, and clustering is one of the other ways to look at the data. We spoke about the various algorithms like agglomerative, k-means, and fast clustering, how it is being done using sentence transformers. We also looked at the way to use sentence transformers, way to use pickle, safe transfers, etc. to save the model. We discussed in detail about how clusters are formed and how you can use it, how the algorithms can be trained to take the new data and put it in a new cluster. So we spoke about those ideas, and then finally we introduced the topic modeling using BERT topic, and then we started discussing about the code. So I believe that you understood a thing or two about clustering using embedding. Do practice the code that has been provided to understand it a bit better, and use your own code. Take some other new information like any of the reviews that is available in Kaggle dataset, or you can go to Hugging Face Up where there's a lot of text data that is available. You can pull any of those data into the Collab notebook and you can start practicing. With that said, I would like to end this video with 4 words as usual. That is practice, 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 practice. See you guys. Have a great time.